Tonight's video is more geometry glee. Yes, we continue with our geometry glee. And we are going to look at congruent and similar triangles. We've already seen the symbol for congruent, and that is this little squiggly on top of the equal sign. And it says that two geometric figures are congruent. It's actually if and only if they have a correspondence between their angles and sides such that corresponding angles are congruent and corresponding sides are congruent. This corresponding word is actually very important. And the way we think about corresponding is which parts match up. So we have a little congruent statement here. This is called the congruent statement, where it identifies the triangles that are congruent. And it's very powerful because I don't even need a picture to tell you which angle is congruent to angle B, because they match up exactly. So that would tell me that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. There is no other option based upon this congruent statement. So AB in that case would have to be congruent to DE. AB could not be congruent to any other segment there. BC would have to be, CA, now think about that one. What would that have to be congruent to? What does it match up with? The only answer is FD. And then BC was congruent to EF. Now I want to talk about notation for a minute, because you'll see that I'm writing these little segment notation things here. And this is what we use when we're talking about things being congruent. If I want to talk about the measure of something, well, the measure of side AB, let's say, is 10 meters. And the measure of side DE then would be also 10 meters. So AB's length is equal to DE's length. That means their length. It's a number. 10 equals 10. When I use this notation, it's saying that I'm naming them. Okay? I'm calling this side is congruent to this side. It's not talking about their length. So it's actually kind of important. Likewise, if I'm talking about angles, okay, I talk about, when we had a little confusion with this the other night, measure of angle A equals 30 degrees. And then the measure of angle B would be 30 degrees. So the measure of angle A equals the measure of angle B. But angle A, oops, am I matching them up wrong? Sorry, guys. Angle D, that should be. But it could be anything here. Oops. So this should be an angle D. Okay? But if I'm calling them by their name, then I use congruent. So I'm saying angle A is the same as angle D. Here I'm saying that 30 degrees equals 30 degrees. Okay? Now if we go back to this congruent statement, I could have written FED is congruent to triangle. I'm going to let you think about it. And it should be CBA. Or if I said CAB, what would that be congruent to? Triangle CAB would be congruent to triangle FDE. Yes? Hopefully you understand that. Okay, you cannot write triangle ABC is congruent to triangle EFD. Not true, okay, because there's not a correspondence that way. So if you look at the next problem, we can be given a problem like this, and we would have to just fill it out. Find the values of A and B. If the measure of angle S is 48, T is 62, the measure of angle X is 70, the measure of angle Y is 4A minus 4 degrees, and the measure of angle Z is 5B minus 3 degrees. So you should be able to set up an equation to solve for those variables. Okay? I know that S corresponds with Y. So I'm going to take this and set it equal to this. And then I know that angle T corresponds with angle Z. So I would set 62 degrees equal to this. And X kind of is just in there. Okay? So why don't you go ahead and solve there for 1 second and come back and check. I got A equals 13 and B equals 13, actually. Alrighty. Similar figures. They are the same shape, but not necessarily the same size. And we talked about this on the first day. So the corresponding angles are congruent, but sides are not. The corresponding sides are proportional. Very important. So for example, if DEF is similar, and we use that one squiggly, to PQR, okay, then they have the same ratio of the sides. So try and look at what the proportional value is there. So 20 to 24 is what simplified? Do, 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 do. Okay, it's 5 to 6. That's the ratio, 5 to 6. Okay, that's what we call a ratio, and I know we haven't done ratios yet, but we'll be doing an extensive unit later, and you should have some background on that. Is it true for the others? Is 15 to 18 5 to 6, and is 25 to 30 5 to 6? Sure. Okay? So then you can have some problems to solve like this. And they tell you that they're similar, so you have to draw a picture and match it out. So it doesn't really matter how accurate your picture is as long as you label it correctly. So I'm just going to draw triangle ABC here and make sure that it matches up with DEF. So I might make this one a little bigger. I don't know, it's sort of similar, but might even be congruent. Okay. So AB is 8, EF is 12, AC is 15, and DE is 16. State which angles are congruent. Well, those we just match up, so you should be able to do that. And here we have to think about, what does AB match up with? Did I draw that wrong? I did draw that wrong. This should be, it's ABC, so this should be DE, and F should go down here, and the 16 should go along the other side. So you have to see, you have to be careful, you have to check yourself. Okay, DEF. So this would be 16, and so these triangles, AB corresponds with DE, and DE is 16, so 8 to 16 is my ratio, so that's 1 to 2. So I should be able to find the missing sides. Why don't you guys go ahead, pause here, and find those. Okay. Let's see. EF, BC corresponds with EF, and EF is 12. Now remember, EF is in the larger triangle, so if I'm going small to large, BC is in my smaller, EF is in my larger, and that's 12, so that would have to be 6, right? So BC is 6, and I would not put the thing on top because I'm actually giving its measure. And then I need to find DF, which corresponds to AC. So AC is 15, and I need to find DF. So DF would have to be, you got it, 30. Okay? All right, so I'm going to let you guys do the next one, and then pause here and come back and get the answers, okay? So for MN corresponds to AB. All right, so I know that MN corresponds to AB, and they gave me a length there of 15 to 45. So 15 to 45 is a ratio of 1 to 3, right? So that, therefore, it takes care of those two sides. NO is 22, so NO is in the smaller triangle, so NO to BC is in a ratio of 1 to 3. Well, NO is 22, so to make that equivalent, we would have to multiply it by 3, or 66 yards. Okay? And then AC is the larger one. Okay? So AC would correspond with, look back at my thing, MO. I don't know what it is. I know that this is 60, so I know that this would have to be divide by 3, and that would be 20. Okay? Gets a little easier once we learn how to do proportions. And the angles, M would correspond with A, N with B, and O with C. Alrighty? So again, notation here, if they're equal, we're going to write AB equals XY. Okay? And if they're congruent, if we're talking about it, we're naming that side, we're going to say, oh, AB is identical to XY, just calling it the name. Here it's like 6 inches equals 6 inches. Okay? For equal measure of angles, we say the measure of angle A equals the measure of angle B. And if I'm talking about them saying angle A is the same, exactly the same as angle B, then I use their names and then I don't put the measure. Make sense? So might want to do a couple problems out of your packets just to review, and we'll do some more review tomorrow. Have a great night.